everyone. Hope what we have done in the previous 2 episodes, you have understood the concept of direction ratios, direction cosines, the projection formula, angle between two lines, condition of parallelism and perpendicularity of two lines. All these formula method already explained. Today's session, I'll be discussing some problems based on direction cosines and direction ratios. Today's class, I'll be discussing to find the angle between two lines when the direction cosines are related by two or more relations. Normally, two relations will be enough because additional condition will be there on three direction cosines of a line or a vector where the sum of their squares equal to 0. If you have taken direction cosines as LMN, then you know L square plus M square plus N square is always 1. This relation is known. Now, if conditions given, whatever, 2 or 3, whatever number of conditions given, this additional condition you'll be using always. So let us take one problem like this. Question arises this manner: find the acute angle between the two straight lines whose direction cosines are given by 2L, 2M minus 2N 0, Mn, NL plus Lm 0, or this one. Question arises, if we are going to find the direction cosines and then angle by the formula cos theta equal to L1 L2 plus M1 M2 plus N1 N2, it will work nicely. There is no problem. But the thing is that for two lines, their direction cosines L1, M1, N1 for one line and L2, M2, N2 for the other lines, how to determine? Because only two conditions are given. So you can get two values of L or two values of M, N or L by M by N, whatever, if you have a quadratic equation. The very first approach is that to get a quadratic equation, and for that we'll be eliminating one of the three, that element we'll try to eliminate from these two. So from first equation it is 2L 2M equal to N. So we're getting N and put it there. In the second equation it is N into M plus L plus ML equal to 0. If you have taken N common, N is what? 2 into L plus M, and this is also L plus M, is whole square, ML equal to 0. So what do you get? It is 4L square plus 5LM, sorry, not 4L square, it is 2L square plus 5LM plus 2M square equal to 0. What you have to do there, you have to find L and M. So this you go by middle term rate, 4LM plus LM plus 2M square 0. Take 2L common, L plus 2M, M common, L. So you got two relations here, and these are two different relations. L plus 2M equal to 0. So condition 2L plus M equal to 0 and N plus 2M equal to 0, they are not for the same line. Obviously, two two lines are going to be involved here. How? If 12 plus m equal to 0, then L equal to minus m by 2. So it talks about one line. Okay? And the second one, if we take the second one correct at if L plus 2m equal to 0, then L equal to minus 2. Or you can write L by minus 2 equal to m by 1. But if I say that these are going to be L1, M1, M1 for the first line, then where does n go? Because you have got all these things from n equal to 12 plus 2m. So n is going to be what? 12 plus 2m. It is 12. You put the value of m over there. M is what? Minus 12. So this is minus 12. Okay. So here L is going to be n by minus 2. Hope you have understood. For the first line you got a relation like what? Where all three can be involved by using the concept of ratio only. That here you got L minus m by 2 and here L equal to minus n by 2. So L will be m by minus 2, n by minus 2. Okay. You can write L by 1. And here what you get? Again, the relation is this only. From here, we got this one. From here, we got this one also. So, if you write L equal to minus 2m, then n going to be from there 12 plus 2m. 2m is minus L. You put there. So, L. So, what have you got here? You have got L by minus 2 equal to n by minus 2. Why? Why L by minus 2 suddenly? Because already we have got L by minus 2 equal to m by 1. Therefore, L by minus 2 equal to m by 1, n by minus 2. Am I correct? So you got LMN over there. No, you haven't got. You got the ratios. But now you have to get exact values of LMN for the first line, LMN for the second line. How to? I just remind you one basic concept of algebra which you have done before. That is, if A by B equal to C by D equal to E by F, then each ratio is equal to under root A square plus C square plus E square by under root B square plus D square plus F square. So this ratio is going to be what? Under root and that divided by 1, 4, 4. Okay? What is the value of L square, M square, N square? That is 1. So here it is going to be L by now I am replacing element by L1, M1 and N1. L1 by 1 for the first line, M1 by minus 2, N1 by minus 2 equal to, this is 1. And here it is under root 9, so 3. So for the first line, L1, M1, N1, this is going to be 1/3, minus 2/3, and minus 2/3. Clear? Similarly, this thing will be equal to 1 by, again, under root 4, 1, 4. That is 9. It means 1/3. And this way you are getting L2, M2, N2. So L2 is what? Minus 2/3. m2 1/3 and n2 minus 2/3. All right. So now we can write cos theta easily. Once you get L1 M1 N1 and L2 M2 N2. This is minus 2/3, 1/3. So cos theta, if theta is the angle, this is what? L1 L2 M1 M2. So 1/3. Here, hope you have understood. These are products over there. So this is going to be minus 2/9 minus 2/9 plus 4/9. This is 0. So theta is pi/2. We have got angle between two lines. They are mutually perpendicular. Clear? And what about the second problem? Second problem, is it different? Yeah, because L plus M plus N 0 and N square M square minus N square 0. Quadratic we can frame, already it is given over there. What you will do? How will you do this? Number 2, you eliminate N. From first one, N is minus L minus M. Therefore, L square plus M square minus N square 0 implies so L square M square minus, so you got 2LM equal to 0. This implies L0 and or M0. So can I get the relation between all LMN over there? In the previous sum I told you, we have to relate with this what we have got. This is for one line and this is for this line 1 and this is for line 2. Here N is minus L minus M. So L0 you put. So N minus M. Therefore, L by 0 and M0 if you put here, N equal to minus L. So what you get? L by minus 1 equal to M by 0 equal to N by 1. Isn't it? Hope you have understood. And for the first line, if we take these three as L1, M1, N1, then each ratio going to be 1 by, because L square plus M square N square 1, already I told you, root 2. And here also 1 by under root 2. So this order triplet, if you write this manner, L1, M1, N1, not order triplet actually, don't be confused. This is 0 minus 1 by root 2, 1 by root 2. And here this is going to be what? Minus 1 by root 2, 0. Okay. So you've got N1, M1, N1, L2, M2, N2. Now cos theta equal to what? Cos theta equal to, again the same manner, L1, L2, M1, M2, N1, N2. So 0, 0 and 1 by root 2, 1 by root 2 half. So theta is going to be pi by 3. So these are kind of sums where only two conditions given, but we are getting all 6 unknowns from 2 known given equations. Okay? Let's see the next type of sum. Now we are going to prove that the acute angle between two diagonals of a cube is cos inverse 1 by 3. acute angle between two diagonals of a cube. So we need to get a cube over there. All three sides are equal. And three-dimensional space, you have the idea to write all three coordinates if the length of the cube is known and the coordinate system taken this manner. I'm just drawing it and then we'll fix up the origin. Imagine this is the cube here. Sorry, let me complete this. This is the cube. Okay? For this cube, the length of a edge is fixed. This you cannot change. We take coordinate axis along these three edges of the cube. This is your x-axis, this is the direction of y-axis, and this one z. And this is origin. Obviously, its coordinate is 0, 0, 0. If length of side be a, this is a 0, 0. This point B is 0, B. I mean on y-axis, it will be 0, A0, this one 0, 0, A. And this is your xz plane, so y is 0. This point has coordinate A0, A. Here, xy plane z is 0, so A is 0. Clear? And this one, yz plane x coordinate will be 0. This one, A, and A. This much idea you have because 3D you have done in class 11, 12 also beginning is done. So this is coordinate. So what are the diagonals over there? Name all these first. This is ABC and you take D here, E, F and this one G. So what are the diagonals? You have to prove that acute angle between two diagonals. Which two diagonals? Not mentioned. My answer is you take any two diagonals. This OG is a diagonal. Agree or not? BF is a diagonal. Agree or not? CD is a diagonal. AE also. You are going to prove that acute angle between any two diagonals going to be that cos inverse 1/3. So we will find the direction cosines of any two of them. Take OG and BF. Take these two. The vector idea, OG vector you can write easily, or you write direction cosines of OG. DCs of OG. What are the direction ratios? DRs of OG are what? A minus 0, A minus 0, A minus 0. That is A. This will be what? A by under root 3 square. Not sigma, it is just 3 square. Okay? So this is 1 by root 3, 1 by root 3, 1 by root 3. Now find DRs of what? We are going to take BF. DRs of BF. B2F. B2F. So this is going to be A minus 0 minus A minus 0. Because A minus 0 I have taken 0 minus A, Z2 minus Z2. So A minus A. And then what are the direction cosines over there? There we got This is your BFR 1 by root 3. Done? Hope you have understood. Now cos theta is going to be what? This is like N1, M1, N1, N2, M2, N2. So this is N1, L2, M1, M2, N1, N2. So this will be 1 by root 3 this plus N1, N2. See, one of the term is getting cancelled. This minus and plus. So what is left over there? That you can see easily. Therefore, so theta is going to be cos inverse 1 by 3. Clear? Let us solve one similar question. Straight line L makes angle alpha, beta, gamma, delta with 4 diagonals of a cube. Then prove that sine square alpha, sine square cube only given, no? So we can easily refer the previous. So same diagram I am going to consider here. Diagonals already I mentioned. OG is one diagonal. BF, A, and DC. They are the diagonals. And that line L makes angles with these 4 diagonals. Lines, direction, cosines, we can assume. Let the DCs of the line be element. One property, one relationship among element is known. For any line, sum of these squares equal to 1. Now, for the vector or for the diagonal OG, direction ratios we have just found a minus 0, a minus 0, a minus 0. DCs are what? DRs you will write DRs A. DCs are isn't it? So OG for BF F minus B, that is A DRs we are writing first. DRs A minus A. DCs are what? A by under root sigma A square, that is 1 by root 3 minus 1 by root 3 and 1 by root 3. BF is done. Now after that we write this DC or CD, whatever. For CD, D minus C, that is DRs are what? A minus A. CD is done and one more is left over there after CD, that is going to be AE. For AE, you write the direction ratios. DRs are what? Minus A. This is what? Minus 1 by root 3, 1 by root 3. Now you write cos alpha. Alpha is the angle made by it with OG. Then how can you write cos alpha? This cos alpha element we have taken the direction cosines. So L by root 3, L1, L2, M1, M2, N1, N2. Understood? Cos beta, the angle made by the line with BF, this is going to be L by root 3 minus L by root 3. And what? That is another L by root 3. There is minus sign in between. Sorry, not L. This is going to be M. And this one N. And cos gamma. How do you write cos gamma? The angle with CD. That is, CD is here. L by root 3, M by root 3, and cos delta clear? There is plus sign here. So you got all three, all four. Now we are going to prove some of their squares. Oh my God, sine square they have given. Whatever, we got cos. From there we can write sine. Now, let's see what happened for cos square alpha, cos square beta, cos square gamma, cos square delta. This will be L plus M plus N whole square by root 3 square is 3. Cos square beta going to be what? Again by 3. And this one by 3 again. And here okay. So now some of these three squares you have to find. By symmetry, all 2lm, 2mn, minus 2, plus 2, all these get cancelled. What is left over there? L square, 4L square left over there. 4m square left over there. 4n square. Rest get cancelled. And this will be 4 by 3. Why? Since L square plus m square plus n square 1. I have not expanded. It means when you are going to answer descriptive, you also don't have to expand. No. You expand it and show your calculation. That is true for your board-based examination. So you got cos square alpha, cos square beta, cos square gamma, cos square delta. Okay, this you write 1 minus sine square alpha. This is four by 3. 4 by 3 means sine square alpha, sine square beta. If you take these four terms together, understood? I have done bit faster because it's a big one. I have nothing to do. Hope you have understood. This expanding a plus b plus c whole square, a minus b plus c whole square, you have to show your calculation in exam. Expand fully in details. Okay? Done? This is a type of sum which is not very common. Pair of straight lines whose direction cosines are given by AL, BM, CN 0, PL square, QM square, RN square 0 perpendicular to each other if this thing equal to 0. Okay? How to start? First thing, the sums we have done so far, two lines, direction cosines L1, M1, N1 for one line, and L2, M2, N2 for the second line can be determined if there is a quadratic relation. But a quadratic relation can be there. It is bit more complicated form. No problem. Can be there. Then angle between two lines, if theta, cos theta going to be L1, L2, M1, M2, N1, N2. Isn't it? If lines are perpendicular, for perpendicular lines, first the condition that L1, L2, M1, M2 and N1, N2, this sum is going to be equal to 0. But how to get L1, M1, N1? These are not numbers. PQR, these are unknown constants. So how to relate? That is a problem here. I'll help you to do it by the method already I have discussed. What is your first step? Eliminate one of them from two given equations. So one of them means that either L or M or N, you should eliminate from these two. So if we eliminating N, then N going to be what? From first equation, minus L minus Bm by C. Now since PL square QM square Rn square 0, you can put this value of N over there. Put it there. Therefore, N square. Okay, minus, no? So now you just C square PL square plus QM square, you write R into expand it. Okay, or this L square is there. You take together P C square plus R L square, A square, L square. Okay, plus twice ABRLM plus C square cube plus okay, here. Now what you do there, divide by M square. Why? That I'll explain. P C square plus R square L by M whole square ABR L by M plus QC square RB square equal to 0. Why have I done this? Because I have to get L1, L2 plus M1, M2 plus N1, N2. And here, there is a chance of relating L1 by M1 and L2 by M2. How to? This is a quadratic equation of L by M. For this quadratic equation by L by M, it has two roots. Let roots be L1 by M1 and L2 by M2. Okay? Roots be like this. because it is quadratic of L by M. Since it is a quadratic of L by M, we take roots this manner. So sum is what? Sum of the roots L1 by M1 plus L2 by M2 and product is what? Product is L1 by M1 into L2 by M2 going to be QC square RB square by, isn't it? So you got this relation now. Now we will take the help of symmetry because symmetry is there in the given equation. No, here you have A square, B square, A, B, C and P, Q, R. A, B, C, P, Q, R. Okay, in two equations A, B, C and you have P, Q, R. So here what you have got QC square plus RB square. See, that divided by PC square R square. So if we write in this manner, then symmetry principle applies. QC square RB square M1 M2 by R square. Any symmetry you got? Definitely. First thing, plus signs only there. Second thing, when you are taking, if we take LM in this manner, when you are writing product of L1, L2, there is QC square plus RB square. When you are writing product of two M's, this is going to be PC square plus R square. If we see that these are equal to N1, N2 by what? Tell what? It will be Q into. No, you leave this here. You take this and this. So it will be Q square plus PP square. Hope you have understood. When we are taking product of two L's, we are leaving this column. It is RB square, QC square. M1, M2, we are leaving this column. Then it is R square, PC square. N, we leave this column. It is PB square, Q square. I have written that only. Assume this thing equal to K. K equal to a constant. Therefore, L1 into what? QC square RB square into K. M1 M2 QC square R square. This multiplied by K. And N1 N2 is Q square PB square into K. Okay? Since lines are perpendicular, so L1, L2 K into QC square RB square K into okay. Now K is a common factor. So you are getting what? Are you getting this form? Check once. You are supposed to prove A square Q plus R. Yeah, it's coming. A square, A square, A square. K common, A square Q plus R. B square, the B square here, R plus P. C square Q plus No, this will be P here. This will be P here. PC square, not Q. P and C square is there also. So you got the relation. K into this thing 0, so this implies the required relation. Q plus R square, R plus PP square. Okay. So this way, also you can derive the condition of perpendicularity. Question is, if the lines are parallel, how do you get the relation? For parallel lines condition, I told you, L1 by L2, M1 by M2, N1 by M2. Best luck for getting the condition of parallelism also on your own at home. You must practice. Under what condition? They must be parallel to each other. Okay?